Okay, Assalamualaikum and good morning to all students. Okay, so can you hear me?
Yes,
Okay, good. Alright, so today we continue our lecture. Okay, right. So last week you already know about course outcome. Okay, course outcome about this subject. Okay, so today we will continue for the introduction of real-time system. Okay. Okay, so basically a real-time system that I think you already know. Okay, you use it every day. Okay, in your communication systems, laptop. Okay, your devices. Okay, so basically real-time is a property featuring timely responses to sporadic external events. Sporadic external event means events that you cannot control lah. Okay, events that you cannot control then suddenly appear to you. Okay, so this course will introduce to students concept of features and requirement of real-time system, including operating system. Okay, so for this course, basically for first or theoretical part, we will learn in the theoretical of free RTOS. Okay, free RTOS systems. Okay, because in real-time system we have many techniques or many languages. Okay, one of them is free RTOS. Okay, so in theoretical part we will cover free RTOS. So because of we just do online, so we will use one simulation tools lah. I think you all already familiar lah with the Tinkercad. Okay, Tinkercad will be used to simulate your project and so on. Okay, but theoretical part in the test and so on, we will use FreeRTOS. Okay, because in FreeRTOS maybe there are some problem to simulate and so on. Okay, so that we use Tinkercad lah. Okay, if in the real class we can embed that FreeRTOS in the hardware. Okay, so like hardware, I believe you are already familiar lah. Okay, you are already familiar with this Arduino board lah. Okay, board also many types of board lah, right? You all learn in MCU. Okay, what else? Uh, okay, other real-time operating system lah, which is some sort like microcontroller and microprocessor, but real-time is more faster than your microprocessor and microcontroller lah. Furthermore, your microprocessor and microcontroller just can be programmed for that specific application. Okay, but FreeRTOS they already update the uh, program. Okay, they already update the application so that every day they come out with the new application. Okay, so the course outcome, which is to design the application in real-time system, manipulate appropriate technique for the time system scheduling and sharing in real-time system, and design a complex system with real-time property. Okay, so this is the textbook that we will use. I already uploaded in the e-learn if you like to read lah. Basically for FreeRTOS is designed by Richard Berry lah. Okay, Richard Berry designed the FreeRTOS. There are other technique also and other authors lah, but we just cover FreeRTOS. Okay, because we don't have many time to cover more than one programming language lah. Okay, so reference manual. Okay, hands-on. Okay, so last time hands-on we can do some hands-on by using Arduino board. Okay, but for COVID we use Tinkercad lah. Okay, hopefully you are familiar right with your IDP and so on, so much more easier lah. Okay, platform software which is Arduino IDE. Okay, so after this we will learn lah today or tomorrow how to install Arduino IDE. Okay, to simulate your program or test your program whether your program is correct without error or not lah. Okay, operating system FreeRTOS. Okay, this website lah. Okay, if you feel free to log in this website, you can see FreeRTOS has many versions. Okay. Okay, real time in ordinary world means at the same time, okay, which means that when you change something, it will immediately change your output. Okay, so the military needs real-time intelligence and real-time news reports. Okay, so because if not real-time, you have lagging and so on, so it will impact your decision. Okay, same like nowadays if you like to read about stock market and so on, right, gold price and so on, so they use the real-time system. Okay, so if you want to predict something, you have to use real-time data lah. Okay, so more professional definition, system whose correctness depends on their temporal aspect as well as their function aspects. Okay, timeliness on timing constraints, deadlines is as important as functionality. Okay, right. Next, performance measure. Okay, timeliness on timing constraint, which is you put your deadline. Okay, deadline when you want to send the signal, because you cannot always open your communication or signal system, right? Because it uses a lot of memory power and so on. So you need the deadline that when you want to send that data. Okay, means you pull the data and then you send it together. Or in real time, you always send the data maybe by 100 millisecond. Each 100 millisecond you send the data. Okay. So speed or average case performance are less significant. Okay. Key property, predictability on timing constraint. This is what I give you example for predictability. Okay. When you want to predict the data before your data comes to you. Okay. So that they used to predict the data. Maybe you have taken artificial intelligence subject and so on, right? Okay, from there you know lah how to predict the data and so on by using AI techniques. Okay, so real time is more faster, means respond within specified time, slow but steady, better than as fast as possible. Okay, example of real-time system, real-time monitoring system, signal processing system, radar, online transaction. Okay, nowadays you use online transaction, right, by using apps and so on. Okay, multimedia like we do now, live video multicasting. Although not really real time, we still have delay, right? So maybe 1 minute, 100 millisecond, 1 second, 2 second, depends on your speed lah. Okay. Embedded control systems such as automotives, robots, aircraft, medical devices. Okay, so whatever you learn, maybe you learn in control system, you learn subject in AI, you learn subject in communication system. Okay, all those subject must be implemented using real-time system. So this is the end subject lah, when you want to implement your application. Okay, so you cannot implement your application if you just learn what we call as fundamental part or fundamental knowledge or theoretical part. Okay, you also have to learn hardware and software. Okay, so that's why you are taking electronics lah. Okay, electronic engineering. Okay, alright, typical real-time system. So you learn digital control system, analog control system, right? Okay, so digital control system periodically performs the following jobs lah, such as, of course, sensor and actuator lah. Okay, the basic things of control system is sensor and also actuator. So sensor is used to senses the system status. Okay, so you want to sense such as your input. Okay, your input basically lah, temperature, what else, pH. Okay, so those are the sensors. Actuators actuates the system according to its current status. Okay, so when your sensor sends some signals, your actuator will straight away convert the decision to what state that you want. Okay, what status that you want. To specify the timing constraints, so you have hard and soft, okay? Hard temporal constraint and soft temporal constraints, okay? To achieve predictability or satisfying their timing constraint. Okay, means you have your timing constraint. You want to send the signal in or less than 100 millisecond, right? So you need the software and hardware that can cover that timing. Okay, soft versus hard. For soft temporal constraint, okay, for example, airline reservation system, if a single computation is late, the system response time may lag. However, the only consequence would be a frustrated potential passenger. Okay, so you have one passenger that late for their flight, right? So then you close the gate and just fly away lah. So we call as soft temporal constraint, which is your decision just impact one passenger only, okay, or minimum passenger. For hard temporal constraint, hard real time is often associated with safety, okay. So hard means that related to safety critical application, okay, mission critical, okay, like military, missing, deadline, okay, in safety critical application that can lead to loss of human life or several economic damage. So we call as hard temporal constraint. Okay, so of course both are constraints lah, but soft has limited impact and hard has major impact lah. Okay, critical. Okay, so for soft to hard, okay, from soft to hard, from examples cruise control, okay, cruise control still in soft, telecommunication are moving to hard, flight control until electronic engine, okay, electronic engine is very critical lah. Nowadays a lot of cars and so on are using electronic, right? Okay, electronic controller. So that's why when you have um, system fault, okay, so you cannot straight away, you cannot use that car anymore compared to last time, maybe manual or engine, manual engine, right? Okay, so you still can start the engine, okay, but for electronic, very sorry lah, okay, you cannot use it anymore. For soft to no real time from cruise control, internet, video, audio, so maybe less than real time, okay, maybe not really full real time. User interface, okay, and also finally computer simulation, which is you no need real time application lah, okay, because you just simulate, right? Okay, you don't have to make it online, okay, or real time. Okay, so why an OS at all? Or an OS is a program that provides an abstraction of the physical machine. Okay, so you have operating system that control your physical machine, provides a simple interface to the machine. Okay, so when you want to control the machine, you need one interface, or like we call as like button. Okay, button. But nowadays we use a operating system that included in the devices. Okay, like software. You don't have button, real button anymore, like switching, okay, like manual switching and so on. Nowadays everything is digital, okay, so that's why you need OS, okay, operating system. Is also a resource manager, okay, a resource manager, which is it provides access to the physical resources of a computing machine. So from your OS, you connect your OS to your hardware lah, okay. OS provides abstract resources, for example, a file, a virtual page in memory, and then maybe some programs, okay. Level of abstraction, okay. So first you have user level. So these are our level, our level is user level, okay. Programmable level, okay. Hacker, okay. Sometimes hacker, okay. Programmable, when you program the devices, you program the software, hardware, okay. Web browsers, shell, video game printer, okay. Under programmable level, system level, okay. So this is what you learn: software, system level, operating system, okay. Virtual memory, scheduler, virtual file system, device driver, okay, driver and so on lah, okay. hardware level, and finally hardware level lah that you learn in mainboard, CPU, keyboard, okay, video card, network card, printer, hardware, hard disk and so on. Okay, so your level, user level until hardware level. Okay, so in user level basically they put the interface lah. So this is the user interface, like GUI, graphical user interface. Okay, abstraction mechanism, okay, application programming interface, API, okay, application programming interface provides a convenient and uniform way to access the one service so the hardware details are hidden to the high level programmer. Okay, so when your function is as an end user, so you just know how to use it, right? Okay, you cannot change it, like your television, your phone, you just can use it, press, install, okay, but you cannot edit it unless you have the uh, programmer password. Okay, so one application does not depend on the hardware. Programmer can concentrate on higher level tasks. Okay. Example for reading a file, Linux or many other Unix OS provide open read system calls that, given a file name, allow to load the data from an external support. Okay. Operating system is an interface between application and hardware. So you have many application, right? Okay, you have application 1, application 2, application 3. Okay, many application connected to your operating system OS. In any OS lah, Windows, iOS, okay, Arduino, FreeRTOS and so on. Okay, connect to your hardware, which is low-level platform. So why real-time OS at all? Large variety of requirements and environments. Okay, critical application like we discussed before this, soft and hard, right? So critical application with high functionality, like medical. Okay, medical application nowadays in 5G technology they use real time. Okay, real time. Doctors can see the patient. Okay, to and from other countries. Okay, so you don't have to come to that country anymore. Okay, space shuttle. Okay, critical application with small functionality. Okay, pacemaker, ABS, not very critical, like tablets, phone, smart card, microwave, and so on. Okay, operating system services. Okay, those are the operating system services. Okay, so first is program development. Okay, of course, first you need to develop your program lah. Okay, basic level, and then execute the program or program execution, access input output devices. Okay, and control access to file, system access, error detection and response, and accounting. As system handles multiple tasks, OS must handle scheduling, interrupt, resource sharing. I think you already know or you have heard about scheduling, interrupt, right? Interrupt, you heard in microprocessor, microcontroller, okay? Resource sharing, okay? So from areas of rapid technological progress and shorten development periods. Demand for reduced development cost. So real-time OS is an answer to this demand lah. Improve development efficiency by using modifying this program. They have a program, but you modify it to maybe to improve your system, okay, or to support new devices. Okay, so meet requests for real-time processing, shorten the evaluation period by simplifying programs, implement general purpose middleware more easily. Real-time operating system is an operating system that supports the construction of real-time system. Three key requirements. First, timing behavior. Okay, timing behavior of the OS must be predictable. Okay, why you need to predict their timing behavior? Because you want to make sure that, or you want to ensure that your data will come in almost real time. Okay, of course, you, like I told you before, we cannot get 100% 0 second or 0 millisecond, right? Okay, in real time, like face to face, but That's why you need to predict their timing behavior. Okay, so that you know what is the minimum and what is the maximum time that that data will arrive. Okay, especially in the critical application lah. Okay, so OS must manage the timing and scheduling. Okay, so your OS needs to know the timing, scheduling, when they want to send the signal. Okay, the OS must be fast. Okay, so requirement predictable, timing and scheduling fast. Okay, do we need OS for real-time system? Not always. Sometimes you don't need OS. Okay, so what type of example that you don't need OS? Okay, so if you heard about uh, maybe ARM, okay, okay, so we don't have to program real-time system, okay, but sometimes they already have the basic, okay, a basic, not really OS, but basic configuration to use their hardware, okay. Loop, okay, this normal lah, you learn in programming, right? You have the loop, you do your and the loop, okay. Cyclic executive, okay, simplest approach is cyclic executive, okay. So for cyclic executive, the advantages are simple implementation, low overhead and very predictable. Disadvantages, cannot handle sporadic events such as interrupt, okay. Code must be scheduled manually, okay. So cyclic executive, which is the simple approach lah, okay. Some sort like RTS, but they don't call RTS, they call cyclic executive. Okay. Basic function of RTOS kernel. Okay, so these are basic function RTOS kernel that you will learn. First, time management. So how to manage the time. Okay, because in real-time system that we discussed before this, you need to predict their time, right? Okay, you need to predict their time. So about the timing. So time management. Okay. And then task management, okay? What task that you want to do first, okay? Task synchronization, task scheduling, interrupt handling, memory management. Okay, memory management basically you want to you want to control your memory lah for power optimization and so on. Exception handling. Okay, so finally is exception handling. Okay, time management. Time management, a high resolution hardware timer is programmed to interrupt the processor at fixed rate or time interrupt. Okay, so when your time arrive, you interrupt that system. Okay, so each time interrupt is called a system tick or time resolution. Okay, so we call as time resolution for time interrupt. Okay, normally the tick can vary in microsecond, depend on hardware lah. Okay, microsecond, nanosecond is too fast Okay, nowadays microsecond. The tick may be selected by the user. All time parameters for tasks should be the multiple of the tick. When system time 32 bits, one tick, 1 millisecond, your system can run 50 days. Okay. For example okay. One tick, 20 millisecond, your system can run 1000 days, 2.5 years, and one tick, 50 millisecond, your system can run 2500 days or 7 years. So you can see from the days and time, okay, you can see the bigger one tick time, the more years that you need to complete. Okay, so much more faster, of course, much more earlier lah, okay, time that you can finish. Task management, what is a task? Okay, task is a process, okay, that you want to do, or thread, or task. Okay, process is a program in execution. A thread is a lightweight process. Okay, so process is a program, but thread is a lightweight process. Okay, so in the sense that different threads share the same address space. All codes data, process status, okay, give shorter creation and context switch time, and faster IPC, inter-process communication. Okay, finally tasks are implemented as thread in RTOS. Okay, so this just term that you have to know lah. Okay, task, thread, process. Okay, normal lah, interview question lah. When you apply for job after this, if that company do real-time system. So these are basic question lah, okay? To know you have learned real-time system subject lah, okay? So top level task states and transitions, okay? So when you are not running, all tasks are not currently running, okay? In the not running state, okay? So not running means your tasks are not in the running state, okay? And then you move to running, only one task can be in the running state at any one time, okay? So of course lah, because you just have one processor or one real-time system, you just can control one task lah, right? So if you want to control more than one task, you need more lah, more real-time system, okay? Okay, so this is very important diagram. Full task state in FreeRTOS. Okay, so this is the fundamental knowledge of FreeRTOS. Okay, so first, when you have input states, okay, you go to ready state. Okay, you have to go to ready state, and you do your task or running. Okay, you're running your task, only one task at the one time, and then give it back to your ready. And then when you want to move to suspended, okay, or you want to suspended your task, suspended part, okay, or suspended state, you do vtask suspend, okay, or you call vtask suspend. So this is the term lah, okay, the term. This is some sort like programming language, but in real-time system they don't call programming language, they call RTOS, okay, real-time operating system. So RTOS for this is vtask suspend, okay, and then when you want to move from suspended to ready, vtask resume, okay, vtask resume. From block to ready, event you call event. From running to block you call blocking API function, okay, and from block to suspended you call vtask suspend, okay. So if you download the soft copy book that I uploaded in the e-learn, okay, you can see more explanation about this diagram, okay. But basically the basic things, maybe you can remember lah, okay? The term, basic term, vtask resume, vtask suspend, call, event, and so on, okay. Next, TCB, okay. TCB is the task control block, okay. Task control block, okay. Task control block. So in task control block, you have ID, task state. Example, your state is idle, okay. Idling, task start, hard, soft, background, priority, other task parameters, period, relative deadline, absolute deadline, okay. Context pointer, pointer to program code, data area stack, pointer to resources, semaphores, okay. Semaphores is one of the part lah in our course information, okay. Pointer to other TCB, okay. Preceding, next, waiting queues, okay. So these are the summary from your textbook, okay. Task control block. Task control blocks are arranged as a linked list, okay. So they arrange task control block, okay, as a link. So a new task can be created simply by adding its TCB to the linked list. For example, task 1, okay, so task 1, you have task name, you have pointer to next task, you have task status, you have task priority, program counter, registers, memory requirements, okay. So from pointer to the next task, it moves to the task 2, to the task name, okay. Same like task 3, pointer to the next task, move to the next task name. So the task control blocks are arranged as a linked list, okay. So this we call as linked list lah, okay, linked list, right. Task management, okay. So task management, we have task creation, create new TCB, task termination, remove the TCB, change priority, modify the TCB, Okay, and then state inquiry, read the TCB. So these are four terms for task management. When you want to create, remove, modify, and also read. So you want to modify, you use change by your priority. Okay. Next, task synchronization. Okay, synchronization primitives. First term is we call as semaphore. Okay, semaphore is counting semaphore and binary semaphore. A semaphore is created with initial count. Okay, so when initial count happen, a semaphore is created, which is the number of allowed holders of the semaphore log. Initial count, of course, one lah, right? So until binary semaphore. Okay. Same weight will decrease the count while same signal will increase it. Okay. So a task can get the semaphore when the count more than 0, otherwise block on it. Next is mutex. Mutex similar to a binary semaphore, but mutex has an owner. Okay, a semaphore can be waited for and signal by any task, while only the task that has taken a mutex is a spin lock mechanism for multiprocessor systems. Okay, so a task wanting to get spin lock has to get a lock shared by all processors, and finally barrier to synchronize a lot of tasks. Okay, so this term is a function lah. Semaphore counting semaphore, mutex similar binary semaphore, has owner, spin lock, lock mechanism, barrier to synchronize a lot of tasks. Okay. IPC or inter process communication data exchanging message passing shareable bounded buffers. Semaphore is the most primitive and widely used construct for synchronization and communication in all operating systems. Okay, so that's why I told you before this. You will use semaphore a lot of this term semaphore ni. Semaphore Dijkstra 60s. Semaphore is a simple data structure with a counter. Okay, number of resources, binary semaphore, a queue, task waiting. Two operations, P function is to get wait for semaphore. Borrows a token key, decrement semaphore counter. V function release or signal semaphore, returns a token, increment semaphore counter. Okay, so semaphore equals to bar signal lah. So when you can see in the right diagram, you can see bar signal stop, okay, and also clear. Okay, you can see red and also green. Okay, example of semaphore to control your data task. Okay, a queue. Okay, so a semaphore is associated parameter as supporting data structure. So from your semaphore control block, okay, semaphore control block here. Sorry. Okay, laser. Okay. So from semaphore control block here, okay, you have your block, okay, your block, your program, okay, and then you have counter, queue of TCB, task waiting, pointer to the next SCB, and then you connect to semaphore, name or ID. So this is the flag lah, okay, this is the flag for your semaphore, whether you want to turn red or green, okay, so semaphore is like switch, right? Okay, then you have value, binary or account, then you also connect to your semaphore to decide whether you want to give red or green light. Okay, and then you have task waiting list such as task 1, task 2, and so on. Okay, so hopefully you understand the term of semaphore by using this flag. Okay, so next. Okay, a semaphore is an object that consists of a counter. Okay, so this is inside the semaphore lah. Okay, a waiting list of processes and two methods. Okay, example function, signal and wait. So you have your method signal, you have method wait. Okay, so you have counter, you have waiting list. So this is the box of semaphore. Okay, and this is your task. Same lah, like previous slide. Okay, just inside the semaphore they have counter and waiting list. Okay, Task scheduling. Okay, so for real-time workload, job unit of work. Okay, so how many works that you want to do? So a computation, a file read, a message transmission, okay, sending message and so on. Okay, attributes or output that you want is resources required to make progress, timing parameter. So when you release here, okay, when you release your information here, of course you want to send your information throughout your time, right? Okay, when you send the information, you have the timing diagram here, okay, where this is your execution time. Okay, so this total from release to absolute deadline we call relative deadline. Okay, so the final one we call as absolute deadline. So this block or blue one we call as execution time. Okay, so in real-time task, so task a sequence of similar jobs. So you have periodic task. Periodic task is very easy to understand lah, because it is in the periodic signal. Okay, so you have P and E. Okay, which is periodic and also time. Its jobs repeat regularly. Okay, periodic, right? So it will repeat regularly. Period is P equals to inter-release time or 0 less than your period lah. Of course lah kan. Execution time or E. So P is period, periodic task. Execution time E. Okay. Equals to maximum execution time, where your execution time must be more than 0 but less than your periodic or period time. Okay, must less than your period time lah, execution time. Utilization U equals to E divided by P. Okay, E divided by P. So you want to calculate the utilization. So for example, if your E is maybe 1, your P is 2. So 1 over 2, you get utilization is 0.5. Okay, so example lah, how to use this equation. Okay. Okay, next, schedule ability, where you want to schedule your task. Okay, so your property indicating whether a set of real time can meet your deadline. For example, for one. Okay, so what is for one here? For one here is PE lah. Okay, predict task. PE for this first schedule or signal is P1. Okay, so this is your first time, and this is your final task. This one is 5.2. So you can see that the 5.2 for one. Okay, so for one, 5.2 is 2 is bigger lah. 2 is bigger than 1 here. Okay, so real-time scheduling determines the order of real-time task execution. Okay, because this is periodic, so you can see every time has the same period lah. Okay, same period 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So it should be here lah after this. Okay. So this is how to draw lah, how to draw the example of schedule ability. Classification of real-time scheduling. Okay, so you have static scheduling. A fixed schedule is determined statically. Okay, example cyclic executive. Okay, that we heard or we discussed before this, the cyclic executive. Okay, and then this fall under static scheduling. Okay, so fixed schedule lah. Okay, means you already code it. Okay, code it or program it. Okay, to make it fixed. Static priority scheduling. Okay, when for static priority scheduling, assign fixed priorities to processes. A scheduler only needs to know about priorities. Example, rate monotonic. Okay, rate monotonic, RM. Okay, so rate monotonic is example of static priority scheduling. Okay, you just know about priority. Okay, need to know about priorities first. Dynamic priority scheduling, assign priority based on current state of the system. earliest deadline first. EDF, least slack time, LST. Okay. So these are the term lah. Rate monotonic, okay, RM, optimal static priority scheduling. It assigns priority according to period and task with a shorter period. Okay, then you execute the job with the shortest period. Okay, for example, this one lah, you try to execute your task within the shortest period. Okay, it's 4, 1, 2, 3, 4 because 4, 5, 1, 2, 3, 4, 5. Okay, this one 1, 2, 3, 4, 5 until 7. Okay, but this is more shorter lah, shorter period. So you have task with a shorter period has a higher priority. So which one has higher priority? So this one lah, okay, shorter period. So this is how to select by using rate monotonic. Okay, RM rate monotonic execute a job with the shortest period. Okay, so for example, your deadline here is missed lah. Okay, your deadline here is missed because you should put previously should here, right? Okay, okay, you should put here 7. Okay, so now you already deadline miss lah, means you already over. Okay, you already over the 5 here. Okay, because previously you are until 5 only. Okay, next, schedule ability. So a schedule is an order list of tasks, okay, to be executed, and the schedule is feasible if it meets all the deadline. Okay, so a queue or set of tasks is schedulable if there exists a schedule such as no task may fail to meet its deadline. Okay, for example, you have new task, you have scheduling here, then you dispatch, you do running, can finally you terminate. Okay, so a schedule is a order list lah. Okay, an order list of your task to be executed. Okay. Next, interrupt handling. Interrupt, which is your call or your return. Okay, sometimes you call new signal or new operation, right? Or sometimes you return to that point. So we call as interrupt. So you saves or you resumes PC. Okay, interrupt equals to hardware initiated call. Okay, so when interrupt pin activated, program control is transferred to interrupt handler specified program subprogram. Okay, so when the interrupt handler ends, instruction next to the interrupted one continues. Okay, of course lah, when you finish interrupt, then you continue lah. Okay, you continue your next instruction lah. Okay, that is the meaning of interrupt. Advantage, just like phone bell. Okay, imagine if phone have no bells at all. Okay, so it's something like interrupt will help you to do maybe program that you are not planned. Okay, you are not planning that program, but you have some process that will disturb you, but really important. Okay, special requirement for interrupt handler should take care not to interfere with main program. Okay, try to not involve or not disturb the main program lah. How about polling? So the program running on microprocessor must read and process data from a peripheral, whether that peripheral has new data. Okay, peripheral is the input lah. Peripheral gets new data at unpredictable intervals. Then how the program determine the peripheral has new data? So you use polling. Okay, polling is the most straightforward approach which interleaves the microprocessor's other tasks with a routine that checks for new data in the peripheral. So you do tasks that we call as polling lah. Polling is simple to implement but not efficient in many cases. So why? Okay, why? Because you need to always check the new data, right? So because basically in your when you do the program, you already check your input, okay, sensors and so on. But polling, you change or your program will always keep check the data. So sometimes you don't have data, but you keep in checking that peripheral. So wasting your time, resources and so on lah. Okay. Polling consumes CPU. See, polling consumes CPU, time and energy. Okay. So, but the advantage is simple. So the processor is totally in control and does all the work. Disadvantage, polling overhead can consume a lot of CPU time. Of course lah, because you come back to your peripherals, right? To check your data, whether your data is ready or not. And but if no data, then you are wasting your time lah and resources. Okay. Interrupts. Okay, so interrupt is like waiting for the phone to ring. Then or like me, someone call me. Okay, so interrupt my class. Okay, so like you in your class, someone interrupt you. Okay, ask you, call you, WhatsApp message and so on, right? So this we call interrupt. So again, polling is like picking up your phone every few seconds to see if you have your call. For example, in this class, I'm always checking my screen. Okay, for example, I'm checking my phone screen. Okay, if someone or important calls. Okay, so it's like I'm checking. So wasting my resources lah, right? Polling. So next, to overcome the limitation of polling, so we do interrupt driven I/O, input output. At the end of each machine instruction, the processor's control checks in pin, okay, or internal pin lah, okay. If INT is asserted, the microprocessor jumps to a particular address at which a subroutine exists that services the interrupt, okay. So you straight away check the INT pin only, okay. So you save you save your resources lah. You are not checking all pin, but you check the INT pin or input pin. Okay, so this subroutine is called the interrupt service routine or ISR because the polling of the pin can be done simultaneously with the execution of an instruction, resulting in no extra clock cycle and efficient interrupt processing. Okay, so this is we call as subroutine. Okay, called as interrupt service routine or ISR. Okay. So they just check your INT pin. Okay. Next. Why cannot? Okay. Okay. So two methods to address ISR address. Okay. So two methods. A microprocessor determines the address at which the ISR resides. So interrupt address vector. Okay. Fixed interrupt address vector and vector interrupt. Okay. So two method lah. Okay. This is just the term lah. Fixed interrupt address vector and vector interrupt. Interrupt driven I/O using fixed ISR location. Okay, so for example, the first step is microprocessor is executing its program, say current program counter 100, referrals input device stores new data in register. Okay, so this the register. Peripheral 1 asserts INT to request servicing by microprocessor of new data. And then the 4 here, okay. 4, microprocessor stop executing its program at store states, including PC. Okay. Microprocessor 5 jumps to fixed location of ISR at program location 16. Okay. Step 5. Step 6, ISR reads data from 0800. Okay. Modify the data and write to 08001. So this step 6, modify the data and write to 8001. Okay, move lah, right? And then ISR returns causing restoration of the microprocessor states to setting PC equals to 100 plus 1 or 101. So step number 7. Okay, step number 7. And then finally, microprocessor resume executing its program. Step number 8. Okay, so this is how the step lah for fixed ISR location. Okay. Organize your understanding. So basically, you have to know what is real-time system. Okay, we already discussed operating system in general. Okay, Why RTOS, real-time operating system, okay? Basic function of RTOS, time management, task synchronization, task scheduling, interrupt handling, memory management, exception handling. Okay, summary lah. Okay, so any question? I will upload notes after class. Oh, no, no question. Okay, introduction just introduction lah. Okay, if no question, we take rest for 10 minutes and we will meet at 11:10. Is it okay? Is it okay?
Okay.
Okay. Is it okay? Is it right? Okay. You are modern generation, right? Anyone use everyone use Windows 10, right? Should be same lah. Or does anyone use Mac OS? So this one for Windows only, yeah? So sorry MacBook, Apple, you need to install virtual machine lah, Windows. Or is there Mac here? Oh yeah, Mac also here, but of course different presentation lah if you use Mac. Okay, and then if your connection is faster than me, you can straight away install lah. Okay, you can straight away install. So if you have problem, you can share your screen lah, so that I can see your problem. Okay, if no problem, you just proceed to install in the C, install in the normal software. Okay, so my one is still for 5 minutes. Okay, so finish. Then okay, because I already installed, I need to uninstall first. Okay, then you install. Okay, so you click 1.8.13. Okay, agree. Okay, next. Okay, next. Install. Okay, so finish, close. Then, uh, if you open your Arduino IDE, okay, in the desktop, okay, open IDE, something like this, okay. But if you see the library, okay, the library here, you cannot find the FreeRTOS, okay. But because mine one I already include FreeRTOS, but yours one basically there is no FreeRTOS lah, okay. For yours one there's no FreeRTOS, okay. So you need to add .zip library, okay. So you need to add .zip library. So first you need to download zip library lah. So from where? From this website, okay. From this website, okay. So this is library for FreeRTOS. So there are so many library. So find the Arduino FreeRTOS. Okay. So type here Arduino FreeRTOS. Okay, Arduino FreeRTOS lah. Okay, so type Arduino FreeRTOS. Okay, so when you type Arduino FreeRTOS here, you will get so many library. Okay. So try this one lah. Okay. Explore embedded Arduino FreeRTOS. Okay. Explore embedded Arduino FreeRTOS. Okay. So because we want the RTOS written by Richard Berry. Okay. Richard Berry lah. If you click other library, there are other authors lah. Okay. So cannot use for this class lah. Okay. Make sure by Richard Berry. Okay. And then you download by zip. Okay. So download your zip file. Okay. And put into your folder or desktop lah. Okay. Easier for you to find. Okay. Download this zip file. So I will share this link, easier for you. Okay, easier for you. I share this link so that all students will get the same library. Okay, how to check?
Doctor,
Yep.
question.
Yes.
Let's say this upload the FreeRTOS from zip, right?
Download.
Is it the one?
Download.
Okay. So if I download from library manager, also same.
Same technique. You also can download from library manager, which is here, right?
Sketch.
Which one? Sketch, right?
Include library.
Sketch, include library manager. This one, right? Manage library, right?
Yes.
Okay, yeah, same. So, but this one quite lagging lah. Okay. So Arduino. There are two techniques lah. By using this one, or you can download in the zip file lah. Okay. So if you use this technique, you can install lah. Click install. Okay. Richardsberry, make sure by Richardsberry lah. Okay, so if you download using website, okay, using website here, download zip, and then you need to install it here lah. Okay, so sketch, include library, okay, add zip file or library. Okay, you add your zip library lah. Okay, so you get this one lah. Arduino FreeRTOS master zip inzip you don't have to unzip lah. Okay, just click this one and open lah. Open. Okay, so I error lah because already there. Okay, I already installed. Okay, go library. Okay, so then you check your library. Make sure FreeRTOS is here lah. Okay, so these are the library for FreeRTOS lah. Header file, routine, event, FreeRTOS config, and so on lah. So we want to use the example basically. Okay, okay, we have more 15 minutes. So I show you some example how to run example. So after this you can run example file example FreeRTOS. Okay, file example FreeRTOS. Okay, here. So you can see file example FreeRTOS. So we have 01 task switching, task idle hook, delete usage, until 11 binary semaphore. So if you click task switching, so it will give you this interface lah. Okay, so you can run it lah. Okay, if you have Arduino board like me, I connect Arduino board, so I have to check my port lah, which port that I use. Okay, port, so this one not available lah, because not connected. Okay, so if I connect, I can select the port lah. So your board Arduino Uno, okay, basically by default lah. Okay, Arduino Uno. Okay, and then you can run it lah. Okay, very fun. Of course, sometimes they have some warning lah, but okay, as long not error should be okay lah. So you compile. Okay, later I will upload lah this video so you I also give the link lah at the end of this slide for you to find the example. Okay, maybe your laptop is hang, okay, maybe slow internet, okay, so you can proceed after this class lah. Okay, if you can follow this class, it's good for you lah. Okay, you save your time lah, you don't have to do after class. Okay, Welun, okay, Welun.
Okay, done.
Okay, good. Okay, so run. Okay, if this is the board, if you like to explore more, it's good for you to buy lah. But this one just I don't want you to buy, but if you like to explore more about this board, you can buy in the Shopee lah. I just buy around 20 to 30 ringgit lah. up to you lah. But for our class, we just use Tinkercad lah, Tinkercad simulator. Okay, so this is the board lah. If you like to buy, I just bought it in Shopee lah. So they give this board and also connector. So I stop sharing first. Okay, so this board. Okay, or if your senior have this board also, you can borrow lah. They give you this USB connector lah. USB connector to this board. Okay. So if you connect, like me, I try to connect. So if you connect, you can upload the code lah. You can upload the code in the board. Okay. So you can see from my second screen lah. Okay. I show you my second account. So this is the board lah. If you connect your board to USB, so it will display blinking. Okay. Okay. So you share the screen. Share the screen. Okay. So error. Or maybe something lah. So I need to check first. Okay, without board first lah. Okay, try to compile. Hopefully no error. Okay. Error, oh no. Okay lah, never mind. Later I try to check. But error maybe because I change software version. Okay. Okay, so have you had any problems? Is it okay to install and at least to run lah? You have same error or you got okay, good result? If error the big memory and so on, should be okay lah. But this one error compile, so I need to troubleshoot lah. Yeah. Maybe version because I change version frequently. Okay. Or still installing. Okay, if anyone is anyone not taking attendance yet? Because we just have 14. Okay, is anyone not taking your attendance yet? Okay, last call to take your attendance for today. Okay, so 15. Thank you. Izzuddin. Izzuddin. Okay, so any problem you face? Or you can complete the task? You can run the slide? Yes, I will upload the slide. Maybe I give you in the WhatsApp first, okay? And then I upload the slide in the e-learn lah. Can run Okay, good. Okay, no problem. Welcome, welcome. Good. Maybe my laptop lah, old laptop. I need to change different one lah. Okay, so you can explore lah. You can explore in the tutorial and so on lah. How to run that one basic lah. I teach you that one example given. The beauty of this RTOS is all program already uploaded in the RTOS website. This one, like this one. Okay, IDE, this one, GitHub. Okay, so that's why they like to use this one. So in work later in industry and so on, you don't have to code it from scratch. Okay, you can download it. Okay, whatever board you use, Arduino, for example, Arduino, okay, a lot of board hardware. Okay, Arduino, C++. Of course, when you work in industry, you don't have time to design from scratch. Okay, when you do it in industry, basically you have 1 month, 2 months to complete the project, or 3 months, maximum 6 months lah. Okay, so basically you cannot design from scratch for complex system. Okay, so that's why we teach you how to use the library, use example. Okay, find the GitHub and so on. Okay, so that when you work later, you know where to find these codes. Okay, so not really easy. Okay, if easy, you don't have to learn lah, right? Not really easy, but this knowledge you can use after you finish your study lah. Okay, it's good for you lah. Not really theoretical, but also practical. Alright, so I think we finished the class for today. If you have question, you can put in the chat. Okay, give 1 more minute. If question, if no, maybe you can say no. No, okay, good. Gio, okay. Right, thank you. Siti. Okay, I stop share lah. Okay, I stop sharing my sharing. Okay. Right, so I hope you can try to run lah this install software, upload and see the library in the Arduino and see some tutorial in YouTube. Okay. Okay, good. Okay, so far so good. Okay. Tomorrow we continue theoretical first lah. Okay. And maybe if I have video and some video or example, I will share lah in the WhatsApp group. Okay. If you want to study more. Okay. So it's like practical class lah. Okay. Alright, so thank you so much. So see you tomorrow. Okay, hopefully I don't have meeting that disturb me. Okay. Sorry for last week. They disturb me to join the meeting lah. Okay. With Ibrahim and so on. Okay. So thank you and get your lunch lah after this. So thank you. Assalamualaikum and good afternoon lah. Right. Okay. Still good morning. Okay. Okay. Thank
Thank you.
you.
Thank you, Dr.
Okay. Bye.
Thank you, Doctor.
Thank you, Doctor.
You're welcome.